Hi, this is Ian Magaha. We are taking a look at the final exam problem number 2. We want to write a Python function that creates and returns a list of prime numbers between 2 and n, inclusive, sorted in increasing order. A prime number obviously is a number that isn't divisible by any other number but 1 in itself, and this function is going to take in an integer and it's going to return a list of integers up to that number. So we have our functions prime list, which takes an n is going to be an integer, and we're returning a list of prime numbers. So I'm going to start a list called primes, and I'm going to start with 2 because 2 will always be on the primes list. This is because we're between 2 and n, and 2 itself is going to be a prime number. We're also going to have a Boolean variable called check. Initially, we're going to initialize it as false. So we're going to have two for statements here. We're going to have for numbers in range from 2 to n, and then for divisors in range of 2 to numbers. If numbers, and I mean, you can just imagine this as I and j right here. If nums has a remainder when divided by divisors that is not 0, then check equals true. Because if there's not a remainder, that means that actual whole number division can be done, and we don't want that. So if we can't get a 0, that means that's prime. Else we say check is false and we just break out. You don't even want to check that number anymore. We already know that that's not going to be a prime number. And then now that I'm looking at this again, I just realized that I definitely could have done this differently instead of making the if statement what I did, but I did what I did. So after checking each and going through all the checks and seeing if it's a prime number or not, we have a final if statement. If check is equal to true and divisors is going to be equal to nums minus 1, this is essentially saying that we've gone through the for loop as many times as possible to check to see if it can be divided by any number from 2 to n. If both of these cases are true, then we want to append whatever that number is. I just realized I definitely could have made this a lot easier on myself by just every time you get out of that second for loop, you just append the number if check is equal to true. So what that would look like, well, let's just see if this works, by the way. So if we go to 100, well, let's go, well, okay, we can just look at it. 2, 3, 5, 7, obviously 11, 13, 17, 19. We know that all of those are primes. 23, 29, 31, 37, 41, 43. These can't be divided by anything besides themselves in 1. 53, 59, 61, 67. These are all correct. Fantastic. Um, yeah, that's great. I don't really need to change this, but I definitely could, but I don't need to. But like I was saying, if you wanted to simplify this a little bit, what you would do is you would go to the end after the for loop. So at the end of the first for loop, every time you go through that for loop, you would just go if I can spell correctly, if check equal true, then you would append whatever nums is. So primes dot append nums. And then this should make it where it's like 2, 3, 3, 5, 5. Yeah, 2, 3, 3, 5, 5, 7, 7, 11, 11, 13, 13. And you can see all these match, so like both of them are gonna work the same way. Um, I guess I'll actually I don't know. This one's easier. It's just we'll go with the one if check if it's true and then append it, because the other one is just kind of silly because you have to run that every single time that you go through the inner for loop, which is just not fantastic. But anyway, do things can we see 2, 3, 5, 7, 11, 13, 17, 19, 23 to 29, 31, and so on. I believe all of these should be prime numbers, so I believe that's all good. So that's how you do problem number 2.